In this video, we're going to try to simplify this function, arcsine of x over the square root of 1 plus x squared. We're going to use x is tangent theta with theta in minus pi over 2, pi over 2. So here we have all the tools that we need to simplify this expression. But before doing that, we need to find the domain here of this function, okay? The arcsine. So here we have two, this is a composite of two functions, okay? And we know that x over the square root of 1 plus x squared is defined for all x's in R, okay? It remains to prove that x over the square root of 1 plus x squared is between minus 1 and 1. And we have seen this one. We know this is always true for any x in R. Okay, so therefore the domain is R. So this function here, the arcsine of x over the square root of 1 plus x squared is defined for every x in R. Okay, now we're gonna use this change of variable. X is tangent of theta with theta between minus pi over 2 and pi over 2. Okay, and we need to note one thing here, is that theta is between minus pi over 2. Let's assume this is minus pi over 2. Okay, so this is just a reminder. So the tangent, okay, so as theta runs between minus pi over 2 and pi over 2, okay, tangent theta will run the whole set of real numbers x, the set of whole numbers r, okay? So here, it's the range of this function here is the set of the whole numbers r. Okay, and therefore we're gonna, as we change theta in minus pi over 2, tangent theta will run the whole set of real numbers. Okay, you have to note this. Okay, and next what we're gonna do is we have x over the square root of 1 plus x squared. We're gonna try to simplify this one based on this change variable. Okay, so we have the domain, we have everything that we need. So we have x over the square root of 1 plus x squared is, x is the tangent, so tangent theta over the square root of 1 plus tangent squared of theta. Here we are trying to simplify this expression. So we know that 1 over cosine squared of theta, or let me prove it, some of you might not know this. So here it's the cosine squared of theta plus sine squared of theta over cosine squared of theta. So I just replaced 1 with this one here, the cosine squared plus sine squared, and now we have cosine squared over cosine squared plus sine squared over cosine squared. Okay, so what's this one here? It's 1. And what's this one? Sine over cosine, it's tangent squared here. Okay, so therefore we have 1 over cosine squared of theta is this value here. And if we flip, assuming all the conditions to do that, so we have cosine squared of theta is 1 over 1 plus tangent squared of theta. Now we take the square root. Okay, so taking the square root, okay, so here we're gonna have the cosine of theta in absolute value equal 1 over 1 plus plus tangent squared of theta. But what is theta? Theta is in minus pi over 2, pi over 2. Okay, let's go back to the unit circle. So here theta is between minus pi over 2 and pi over 2. So the cosine, when theta is in here, between these, between minus pi over 2, pi over 2, the cosine is always positive. Therefore, we don't need this absolute value here. Okay, so I'm going to use this one here. So 1 over 1 square root of 1 plus tangent square of theta is just, so this gives me tangent theta times the cosine theta in absolute value. But having said that the cosine is always positive, when theta is between minus pi over 2 and pi over 2, I'm going to get rid of the absolute value. And therefore, I have this value here is just tangent theta times cosine theta. Now, this is just using that tangent is the sine over cosine. This is just sine theta. So now I have shown that this value here is, if we change x to tangent theta, this value here is just sine theta. Therefore, if I take the arcsine of x over 1 plus x squared, square root of 1 plus x squared, is going to give me arcsine of sine theta. Okay, so now what is theta here? Theta is minus pi over 2, so we have a bijection between arcsine and sine, and therefore this is just theta. So this value is just theta. Okay, now I go back to my change of variable, so I have x is tangent theta. Now, if I take the arctangent of x, okay, because arctangent is defined on the set of all the set of real numbers. So here I'm gonna get arctangent of tangent of theta. But since theta is between minus pi over 2 and pi over 2, the arctangent and tangent are bijective, okay, inverse function of each other, and therefore I have just theta. But I have proven that arcsine of x over the square root of 1 plus x squared is theta, and the arctangent of x is theta. Therefore, this function here is the arctangent of x. So I have shown that if one simplifying that the arcsine of x over the square root of 1 plus x squared is the arctangent of x. Okay, and that's what I need to prove. Okay, is there any other ways to show this result? Yes. Okay, so here what we can do is, okay, what we can do is we can define a function f of x is the arcsine of x over the square root of 1 plus x squared. Most of the time there is this pre-calculus checking and verification using trig identities and inverse functions, but there is also a new way or another way, it's which is based on the differentiation. So once we try to differentiate, we're gonna get something familiar here. So here we remember that the arcsine, let me call it another function, g of x, arcsine of u of x. So the g prime of x is u prime of x over 1 square root of 1 minus u squared of x. So if we do that, if we do all these steps here by taking u of x as x over the square root of 1 plus x squared, and we know this is the arcsine. If we do this for f, so what we're gonna get is we're gonna get that f prime of x is 1 over 1 plus x squared. And we know this, we know a primitive of this one, or a function. So here it's just the arctangent of x plus c. So f of x is arctangent of x plus c. And if we take x to be 0, okay, so we know that this is plug 0 here, arcsine of 0 is 0, and arctangent of 0 is 0, therefore we get this c is 0, and therefore my function f of x, which is this one here, is simply the arctangent. So this is another way using derivatives. Okay, it's a bit longer, but this is elegant, but you have to be careful with the definitions and where your functions are defined with the domain, the codomain, the range, and using these inequalities and equalities that we have seen in pre-calculus. So this is all we have. If you see any errors or mistakes, please let me know. Thank you very much.